let's say a test case builder is taking a long time. That's an example I usually use here. If I look for test case builder here, this parameter, I can disable test case builder. How do I disable test case builder? I execute this API, and when it says name, I say test case builder, that is the name, and when it says value, I pass the value of no. Is that clear? Okay, any other questions that we may have? So that was the health check. So you saw the health check running. I gave you a demo. There is another skill that's called SQL health check execute, which is like SQLT execute. Instead of passing the name of a SQL ID, you pass the name of a script. And it's doing exactly the same, but execute the SQL. It mimics SQLT execute. That's why it's called SQL health check execute. Test case creation. I already demoed this, but let me explain you what it does. Why do we need a test case for SQL2? We're cloning here, right? Test case is like we're trying to clone. We're trying to clone this SQL and the environment around the SQL and put it on a different database where we can mimic the same behavior. So that is why. That's why we need a test case. Why do we want to do that? Because we want to apply what if. Once we have the test case with the execution plan that we saw on the source system, we want to be able to play with it. That's why we need a test case. In some cases, we want to investigate unexpected results. What is this unexpected result? Let's say this SQL is returning 3 rows and you were expecting 4 rows. You say, you know what? I think the SQL is incorrect. There is something going on with the SQL. In those cases, you also need a test case. Okay? I don't want to go into a lot of details about unexpected results, but it happens. It happens that you may have the SQL, you were expecting this many rows, and the output is not exactly what you were expecting. And in some cases, it could be a bug. Okay? So you also need a test case. When you are trying to replicate this case, just be careful. These two, they look alike, but they're not the same. Okay? So sometimes you say, okay, how this case? Well, it's almost like, no. It is, but it is not. Okay? Just be careful with that. So how do we create a test case? We require usually 2 steps: extraction and implementation. Extraction, it happens on the source system. Implementation happens on the target system. SQLT, what it does, it gives you this part already. Every time you run SQLT, you have the extraction. So that means the only thing that you have to do is implementation. How do we implement a SQLT test case? This is what I demoed already. You unzip this file, go to the README. The README is going to give you the instructions on how to do this. And go to the README, get this file, unzip it, and execute the express. That's it. That is the test case implementation. There is another test case which is called test case express, which is this TCX, which is even faster than this one here. This is something new. I'd rather use this one here, even though this one takes a little bit longer. This is more powerful than this one here. This one may not handle columns which are system generated. Like, for example, if you have extended statistics, it may not bring over the extended stats. If you know for sure you don't have system generated names for column, you're fine with this one here. Otherwise, we have this one here. This one, I'm not going to say here that even a monkey can use it, but no. This one is basically an easy way to do it. This is for development, actually, because development, they have a requirement. Going through these steps, it may be time-consuming. So they say, we want something faster, and this one is faster. Anyway, that's a different story. This is mostly for internal use. So summary for SQLT. How do we diagnose and resolve SQL performance issues? Or in other words, how is the SQLT help? Well, it helps in different areas. One is that it produces everything that we need for SQL tuning. And when I say everything, it's like, according to our experience, and not only Abel and myself, but a lot of people, it's like, we have on SQLT what we need for SQL tuning, and even more. We usually don't use everything. But usually what we need is already there. Is that clear? So that is what we have. We have over 100 of health checks around a SQL statement. We have the automatic test case extraction. It also generates SQLT Advisor. I didn't show you the SQLT Advisor report, but it's also included inside SQLT. There are some pieces like, for example, commands. Let me just show you what I mean here, plan stability. Remember the cases I showed you as an example that we have, for one SQL, we have multiple plans. Let me just show you here. In this same case, if I look at execution plans, it comes with several plans. Look at the performance of this plan. This plan performs in 0.2 of a second. This one takes 42 seconds. Different performance. Of course, the number of rows processed is different. But let's just say for a second that we like this plan very much. We want this plan. Or maybe we also want these two. We want these two plans. How do I create a baseline for this plan? I see the plan here. And how do I create a baseline for this plan? The question is, I look at my SQLT, I notice there are two plans that are good, everything else may be questionable, so I want to create a baseline for these two plans. How do I go about creating the baseline? Remember what we learned yesterday about how we create a baseline? We take the SQL, we run it twice, but think this way, I already have the report, I already have the plan. I just want to be able to grab this plan and create a baseline.
You can use AWR report.
We can use AWR. Well, if the SQL is coming from this AWR, these two, where are they coming from? In this case, they were coming from memory. But this report, when was this report created? This report was created on February 4th. So they were in memory a few days ago. They're no longer in memory, right? So maybe if I was lucky, they were captured by the AWR, but maybe they were not. But anyway, I have those plans here on my report. So how do I take those plans from my report and create a baseline? Can I do that? APIs, I can use with the hints, but instead of going to the hints, I open this README and look for an entry here that says what? Create SQL plan baseline from SQL set. If I open this up, it says you can load one of these plans into baseline, right? If the SQL was coming either from memory or AWR. This method works on the same system where the SQLT was created. So that means if this report was created here on the same database, I can just, for any of these plans, let's say this is the plan that I want, I just take this API and run the API. So I give you the syntax, it's just a matter of cut and paste. What is happening, if you look at the API, what is that it doing this API? Load plans from SQL set. And this plan, the D1316, is already as a SQL set. So that means every time I run SQLT, it's going to create a SQL set for every plan that you see here. Create a SQL set. It doesn't implement the SQL set, it just creates a SQL set. Why? Because it's possible that a couple of weeks later, you say, you know what, I can no longer do this plan. It's no longer in memory, it's no longer in AWR. But I saw it here. Can I grab it from here and implement the plan? The answer is yes. Why? Because when you run SQLT, it creates a SQL set. The SQL set is permanent, it's there, and it's just ready to be used. Take it. Just take this API, run this API, and you get the plan. No, SQLT, those always are permanent. And it doesn't matter. It's a tuning set, it belongs to the data dictionary. Actually, that's a good point. It's created in two places. It's created in the repository, SQLT repository, but even if I remove SQLT, still the tuning set is there because it's part of the data dictionary. It's created in two places. This API is using the tuning set from the data dictionary, which is not doing any harm. It's just staying, it's a standby on the SQL set in case you decide to use it. Okay? Now, let me make it a little bit harder. Imagine this file is coming from development, and you want to take this plan and put it in production.
Actually, Carlos, before you go further, can you just go back and show one line? How do we get that? How do we manage to actually do the things
How do we get this file?
from where?
This is the README, this one here. The README is dynamic. The README that you see inside SQLT, yeah, usually we go to the main report. Main report is here. This is the README. The README is like, what else do I do? I mean, I have the main report to do diagnostics. The README is, what do I do next? What is I can do? So in this case, the README is telling you that you can create a baseline out of the SQL set. Why? Because every time you run SQLT, it creates SQL set for every plan. So you have one plan here, you have another plan here, you have another plan here, another plan here, and so on. You don't have to implement all of them. You can choose and pick, I mean, whatever you want.
This is much more better than the other way.
This is much better than the other way. Which other way?
Like just going the other way, like branded. Yeah. Like
Yeah. Yesterday I showed you how to do this manually. Today I show you how to do this through SQLT. Okay? Now I'm making it a little bit harder. What happens if this file is coming from development and you like this plan and you want to take this plan and put it in production? You have to do an export import of what? The tuning set. Tuning set. So this is what it says here. If you read carefully what it says here, it's going to tell you exactly that. It's going to say, this method only works on the same system where SQLT was executed, unless you first restore a SQL set from a different source, let's call it development. You can restore a SQL set from development, and then follow this API, which basically means 2 steps. You click on this link, and it says, how do I restore a SQL set? So now think this way. This file is from development, and you want to implement the baseline in production. So you come here to restore SQL set. It says, oh, I need to import the SQLT repository. Why? Because the SQLT repository also contains the tuning set. So how do I import the SQLT repository? This is the command. So I take the repository from there and put it into production. Use the SQLT repository. And after I do that, I execute this API. This API is going to unpack the tuning set from the SQLT repository to the tuning set inside production. And after I do that, I can execute this step. Is that clear? If I am...
What would happen when you are importing the repository of SQL tuning set from different? Like it takes only for the particular SQL.
For the particular SQL. For particular SQL and particular plan. Each
so
tuning
it doesn't impact any other...
Nothing. Nothing. The tuning set, the name of the tuning set, you can see that here. It contains the SQLT ID, the plan hash value, and if it is coming from memory or AWR, there are no collisions.
So that can you pick the SQL set?
Yeah, and the other one you also pick here. The SQL set is the one here, which implies SQLT, that is the statement ID. It has the plan hash value, and it has where it's coming from. Where do you get this? On the README. The README file. Okay, the tuning set is created by SQLT. This number 53240, it matches the name of this file, 53240. So that means every time you execute SQLT, even for the same SQL, it creates a different SQL set.
Yeah, but that SQL statement has a multiple plan hash value.
The SQL statement has multiple plans. Yes, that is correct. It doesn't matter. Every plan includes, as part of the name of the tuning set, the plan hash value.
Is that like, I think also if you go back to that other screen where you had that different hash values, I think this might give you that information.
Yeah, this one here, let's say, what is this?
Is it like a deep creating a name or is it like auto?
The name is created by SQLT. It's not system generated, it's SQLT generated. So I avoid collision by...
Okay, so one final question.
Yeah.
Is that name, the previous screen, from the README file?
From the README, here.
If we select, we take this name and search in the select SQLT, can we find reference to this one?
Okay. This value, 53240, that is the statement ID. and this value 24 blah 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 316. Look at this 316. 316. That matches the plan hash value. Yes, yes. Every plan for every SQL, for every execution of SQLT generates one SQL set. Okay? So you can select which one you want to implement. If they are on the same system, it's very easy because you only need to execute this API. But if it is a different database, it requires three steps. Import the repository, restore the tuning set, and execute this API. And to import the repository and restore the tuning set, the syntax is here. This is the syntax to import the repository, and this is the syntax to restore the tuning set. Now I can go ahead and do it here. Is that clear? So I can play with my plans. I can take from a SQLT that is 2 weeks old, or maybe 2 months old, I can take this plan from development and put it in production.
All the table names will export equal. The table names are different?
Doesn't matter. The plan is associated to the signature of the SQL. The signature. Of course, it's assuming that your two environments, they have the same objects. Okay? If on development you have table P1 and production your table is P5, it wouldn't work. It's related to the same SQL.
But in the import, you should have but in the import, you use the import data pump or regular import?
It's export import. We saw that here. I give you the command here. This command is just a standard input. Import of what? I import the repository, right? And after I import the repository from one database to another database, I just need to restore the tuning set and then implement the baseline out of the tuning set. Is that clear? It's kind of confusing. It's clear?
You're exporting the tables that start with SQLT in that import.
Okay. Let me go back. Yes, when I do every time I run SQLT, it exports SQLT repository. Inside the SQLT repository, I have many objects. One of the objects is the tuning sets associated to this SQL out of this execution. So if I just run this API that I have here, I take the tuning set from the data dictionary. Straightforward, from the dictionary. So that means when I run SQLT, it creates a tuning set for every plan on the data dictionary. And then it puts the tuning set also on the SQLT repository. So I have the tuning set in 2 places, inside SQLT and inside the data dictionary. If I want to implement a baseline out of the tuning set, it's going to take the tuning set from the data dictionary. But if I want to copy the tuning set from one database to another database, I already have the export. So I take this export, do an import, and then restore the staging table into the tuning set. How do I do that? These are the 2 commands. This is the import, and then this command is doing the unpack of the tuning set from where? From a staging table that is part of SQLT into the data dictionary by using this name, and this name matches one plan for one SQL.
Okay.
Once I do that, then I can do this on my target system, because now that plan exists, and it's the same plan. This name is the same. Now the plan exists as a tuning set.
Yeah, but Carlos, the only thing is that, at least I'm confused about is, so everything is understood what you just said. What is confusing to me is that, that name in between the plan hash value. Now, in order for me to actually make this active, this particular tuning set, I need the entire string, not just the hash value, right? How do I get that entire value?
The string is here. I give the exact syntax. It's just cut and paste.
From where? From where do I get
From the README. This is the README that comes with SQLT. Every time you run SQLT, it includes the README, and the README contains the commands to cut and paste.
Yeah, this file is basically dynamic generated.
SQL segment is the one we have to concatenate and generate into the SQL hash value and plan.
But it's already there. You don't have to concatenate anything. You just
Where
need.
do you find that? That's what I'm saying.
Where do you find what? I mean, if you look here at the plan summary, like Able is going to try to explain this different way.
Let me see if I can give let me see if I can keep it right. You do a SQL extract on the on a development system. Okay, so you have all those. You see all those lines as well. Now, when that SQLT extract run, it used the API to create the tuning sets, and the API of the created tuning sets, you can either let the system decide on whatever name he wants to do, or you assign your own name. So Carlos made a specific name for that tuning set. So the SQL set already has the name, a specific name that was generated at the moment of the SQLT extract was done. Instead of letting I can see what you're trying to say. Well, how do I find out the name? Because you believe that the name is automatically generated by the system. But no, the name is actually given on creation time by the SQLT. So then, because Carlos knows how he constructed the name, then that name follows that SQL set. It's stored in the repository. So when you export it and import it into the new system, that name follows you, and that name is persistent on that SQL set.
Okay, because I was only looking at that plan summary HTML page, right? And in that plan summary, it gives me a list of like 10 different plans.
Yes.
And all I know is that okay, I want to use one of that plan, which is a good plan, right? So in order for me to get that plan out, I have to do the process.
Yes.
I was just mentioned, right, that all I have to do is I have to go to the README of that particular hash value, and then open it up, and then just cut and paste. Is that how it's supposed to be?
Yes, because already SQLT made all the necessary calls to export it and have it ready for you to import it when you need it. Let's say that you didn't have the SQLT. So you already find by making queries on $, views, you already found the specific, the one that you want, the specific hash value. So you have to go to the system again, run a DMS SQL API, and get the plan hash value, then query it again to get the name, the SQL plan name, and then create the tuning set, create the staging table, export it into there, then export it from the to disk, then import it into the other one, and create the table, import the other one, and then unpack it, and then so. You see, all these steps were already automated, were removed when the SQLT ran, because the only thing you need to do is either import the repository, and it will have all the necessary items for you to just cut and paste without any editing. You don't need to change any of the names. The names are dynamically generated already and ready to be used. So you just cut, paste, put it, and that's it.
So the SQLT, when the readme file is created,
I think the question is, in the README, you have only one sample, or for every plan ID?
Every plan has a block.
Okay.
Let me show you the README.
It is
just
not
copy and paste whatever you need.
It is not a sample.
Okay.
It is the actual statement. And if you have 6 different plans, you will have 6 statements, because they are the actual blocks to execute.
Yeah.
There is no sampling, no cut them by here and edit this part. There is no something. They are all ready.
There will be 6 HTML files,
Right.
you're saying.
No. In the same HTML file, there will be
Same HTML file.
6 blocks, 6 different that says this one belongs to this plan hash value, that one belongs to that other plan hash value. All 6 are going to be.
Okay, demo time. Okay, I show you here from this one. I say, okay, I have these different plans, right? Let's say I want this 316 out of the report, and this report was created on a Linux machine some other place. I already created a test case for this one here, right? So I created this case, I have the others, I have everything, I already import the repository. So when I come here to the README that says, if it is coming from a different system, I have to do an import repository, I already did. So that means what I need to do is, I take the one that I want, this one is 316, this one is 003, and so on. Or let's say the one that I want is this one here. And I execute this one here. So I just did, as you were talking here, I just executed this one here on my local machine, and it says successfully completed. And after I do that, I take the same 316, took this piece that you see here, that SQL block, and execute it. And this is what you see here. When I do that, it says plans is created one, and it renamed the plan. So the plan that I just created on my local machine is basically this plan. I just copied this plan and put it as a baseline on my local machine. I just did that. Okay? If I want to do it again, let me do it again with another plan. Let's say I want this plan, the 003. So I come here and say, do I need to do this import? No, because I already did, right? So now I'm looking for this 003, which is this one here.
So how do you get that 003? I think that's where I'm
from here, from the plan summary,
yeah, you got that 003.
Just select whatever I like. Okay, so I took the 003, which has a good performance, right?
Right.
So I took that 003, execute here, and it says successfully completed. So that means when I am doing this, I have a tuning set, but I don't have the baseline yet for that plan.
Go back to the README part.
Go back to the README.
You see 6 blocks and 7 blocks. So you get generated automatically.
Everything is created automatically when you run SQLT. Now, what I have to do now is find this one, the 003, which is here. So I take this API and run it here. Once this one completes, I have two plans on my baseline for those two plans.
Can you show the plan?
Can I show the plans?
What do you expect to use? Plan B? Plan
Hmm?
No, running with the script.
With the script?
The plan B. What's the plan B?
Yeah, the plan B will be required to pass the string. So I'm just going to select start from DBA SQL plan baselines. It's going to come with many rows, but it's okay. Set in. And here I will find several rows. This is the other SQL, the one with the T1. Let me see which SQL we have here. I don't even remember what was the SQL. So let me go back and check. The SQL text is this SQL. So if I look for that SQL, there we are. We can see the SQL. We see the name of the plan. It was manual load, right? These are the two plans. These two. The 003 and the 316. Are they enabled and accepted? I don't recall if they come enabled and accepted. Enabled is this one here. And accepted, where do we see accepted? Accepted is this one here. Enabled and accepted. Enabled, yes. Accepted, yes. Why is it coming enabled and accepted? Let's check the API that we're using here. It says blah blah blah. Load. Alt SQL plan baseline. I change the description. I change the plan name. But when by default, when I load a plan from SQL set, the default is they become enabled and accepted. When I do the auto capture, they don't become enabled and accepted. But with the load SQL plan from SQL set, by default, they are enabled and accepted. Okay? Any questions here? What is the worst thing that may happen? Let's say by accident I took a bad plan, and that plan is I don't like that plan. Then I can always go back and using the API to change the status of the plan, I go from enable to disable. So it's not, you have a question?
If I install this SQLT in production,
Uh-huh.
so I run it on the test and save my data in a separate database, and I like the SQL set and then it back to production. But before that, I uninstall the SQLT, it won't matter.
You, before doing what?
Let's say in production, I remove the SQLT altogether once I took the export of the data. Then I need to import it again in production.
Yes.
To implement this.
Yes.
Is
Yeah,
that-
but you don't need to reinstall SQLT. You just follow these steps. So you will need an account that says SQLTXPLAIN, like in this case, but you don't have to install it. Just import the repository.
And if I run SQLT again, let's say take another dump, all these numbers will change.
Yes, that's a good question. You notice every time you run SQLT, we have this statement ID. In this case, it says 53240, right? And if you install SQLT, you will get a different number. And you install it again, you get a different number. Every time you install SQLT, you get a different number. Why? Because this is a sequence, but the sequence starts with a random number. So if you install SQLT in production and development, you have different numbers, there is no collision. The chances of a collision is like 1 in a million. Okay? So no collisions here. Okay, so that this topic, it wasn't necessarily inside the topics I wanted to explain, but it is a little more advanced, but for you guys it is very important. I mean, to be able to, you know this plan, you can take this plan from SQLT and move it from one database to another database. No issue. Okay? Questions? Questions here? How do I do cleanup?
Clean up those SQL sets that you know for sure that you won't need them anymore.
Okay, if you want to do the cleanup, you can use a standard API to do the cleanup. I mean, DBMS and SQL Tune, or SQL sets, they have an API. Let me show you an example of how do we do the cleanup. It's not that we want to, I rather have those in case I change my mind. It's like a backup plan. I always have that created. It's not like it's a lot of data because it's a tuning set for one SQL, one plan. So that means it's very little. So I'd rather have it and delete it. But if, let's say I want to delete that. I can use something like this. SQL tuning set. I have to delete the SQL plan management, but the SQL tuning set delete. I have this API that says drop SQL set, and I pass the name of the SQL set and the owner. Where do I get the name and the owner? When I show you those tuning sets here, this is the name and this is the owner. So that means if I run that API and pass these names and this owner, I can delete those tuning sets. If I want to. In general, I'd rather not to. Okay? Any other questions? Yesterday I mentioned something about you create a baseline for a modified version of the SQL, and then how do you attach the baseline or the modified version of the SQL to the original SQL. Remember that we mentioned that? And I mentioned, yeah, we have a script to do that. Yeah. Which script is that? Let me just show you here. On the material, when you look at tools and you on SQLT, you go to UTL, you will find this script that is called COE load SQL baseline. It is the material. When you open this one here, just read the description. So the description is very clear what it does. Just take a moment and read the description. Is that clear what it does? So this is like an easy way to associate a good plan with a SQL that you cannot modify, but only with hints. But the hints, when you put the hints, are temporary because you cannot modify the application, right? So then run this script. it's going to ask what is the original SQL ID, what is the SQL ID of the modified SQL, that means the one that has the hints, and if that one produces multiple plans, which is the plan that you like. Okay? And when you're doing this and you run this script, it's going to do exactly what it says here in the description. This works on 11G, because in 11G we have baselines. If you want to do something similar on 10G, then use this one here, COE load SQL profile.
So basically, you're replacing the hash, plan hash value.
You have to go through this script, but yeah, it has to do with the hash, with the signature, not the hash value, with the signature.
Yeah.
Okay?
So it's enforcing the hit basically.
Let's say you have this plan, it's a bad plan, right? But you know that if you put a hint, you get a good plan. The hint could be a full table scan, could be an index, could be leading, anything. You get a good plan. Fine, you have part of the solution, you know the good plan. But now your challenge is, how do I take that plan that I can only produce with hints and associate that plan as a baseline attached to the original SQL, not to the modified SQL, but to the original SQL. So when the CBO parses your original SQL, it's going to use the baseline of the modified version.
So basically it's stored offline.
No, it's a SQL plan management, it's a baseline. It's not the store outline, it's a baseline.
I mean, but in that case, the baseline only can have this one plan now. Otherwise,
No, you can have multiple plans.
but Oracle may not choose this one.
Oracle may not choose this one
Here,
here.
if I have a 3 plan,
Uh-huh.
this is modified to one of them. Yeah, but when I run the original query, how can I guarantee the query only use this?
Only to use this one here? Yeah, I agree with you. I can make this one the only plan. Or if I have multiple, I make this one fixed. So always using the same plan.
Yeah.
Okay? So I can do the same with baselines. I can do this with profiles. So these are just techniques. I mean, how do we transport an execution plan from one system to another? Could be on 10G, could be on 11G. If it is 10G, I use SQL profiles. If it is on 11G, I use SQL plan baselines. Okay? Let me go back to the PowerPoint that we have here. We were almost there with this PowerPoint. So some notes that we have. Of course, we have the note for SQLTXPLAIN. We have the note for SQL health checks, a couple of notes for frequently asked questions, and this is my email. Yes, you can send me an email. It doesn't mean I'm going to answer, but you can send me. No, I usually answer all the emails, yeah, and I don't mind. I mean, questions here, questions there. I mean, that's part of my job. I mean, that's what I do. And I also give you this blog. I have a blog. So you can look at the blog. I do some entries on my blog, and for example, I had to write a blog about this topic that we just discussed. I mean, how do we get the baseline from this system to this other system through SQLT? I haven't talked about that on any blog, so I need to write about that. And there is no in between. There is no in between. That is true. I mean, I know some of you guys will say, I want this class to be over, I don't want to see SQL ever again. I know that. I don't take that personal, okay? So, but if you are one of those few that you really like SQL tuning, there are some SQL tuning gurus. I'm not a guru. I'm just here. I mean, my contribution is SQLTXPLAIN and a few things. Well, who are the gurus? I give you just 5 names. There are more names. But if you want to find the gurus, just follow these people. Follow Maria Colgan, Jonathan Lewis, Karin Insaf, Christian Antonini, Guy Harrison. I can give you more names, but I think you can start with 5 names.
Where is the Tomcat?
Tomcat, the way I see Tomcat is more like general. He knows a lot about many things. But for SQL tuning, I think these guys here, they have a deeper knowledge of SQL tuning. Say again? I have seen it. I haven't gone through his book. He has a book on SQL tuning. Once I go through his book, but I know it's good, but it's not my personal experience. I need to go through his book. I have his book, but I haven't had the time to read that. Yeah, keep in mind this list is not all of them, it's just giving you 5. So it was hard to say which 5 I should put here. These are the bullets, okay? So you may want to follow them. And that is what I have for this PowerPoint. I have 2 more PowerPoints to cover, which is like 2 more hours, okay? Now, the good news...
You're fine.
I'm fine. I'm already talking to myself on the table. Anyway, the good news is the content of those PowerPoints, I already explained those. So I'm just going to show you what is the content because it's deeper to what we saw here. I'm just going to go quickly through those PowerPoints so you see what they have. What you will notice, everything that I said is already, everything that is on those PowerPoints, I already mentioned that somehow. So let me just go back and show you those 2 PowerPoints. Yeah, according to the agenda, we have SQL Health Check, which is on SQL Tuning version 1, that is number 12A and 12B. If I go to 12A, I'm going to open both and 12B. I'm going to close everything else. So this is what is left, those 2 PowerPoints. On 12A is talking about how do we improve the performance by looking at health checks. So this one, it says, well that is me, well, some people say, oh you look younger, oh no you look older, so I don't know, I just like that picture. That was the last time I was wearing a tie, so that's why I keep that picture.
You were actually expecting me to look like that.
The most,
I was looking for almost, right?
so now I look younger, thank you very much. Okay.
Do I get prize?
I don't have more prizes. I can give you a business card. So anyway, this one it talks about the health checks and do a demo. I already did the demo. So what kind of health checks we do? I mean, first it's talking about what is the health check, what is the input, why do we want to use SQL health check. Sometimes working on a health checks may improve the performance. This is a fact. Sometimes you look at these health checks and you say, oops, I dropped an index. You put the index back and you get the performance. It's true. It's not always the case, but sometimes it happens. Sometimes you just want to do a quick sanity check around your SQL. Now, when do you want to use SQL health check is when SQLTXPLAIN is not an option. If SQLTXPLAIN is an option, you want to use SQLTXPLAIN. That is choice number 1. If for any reason you cannot install SQLTXPLAIN, SQL health check is the second best. How do we do that? We download the tool from this node, execute, connect to assist, 2 parameters. If you have the tuning path and what is the SQL ID. When you look at the observations, you don't work on every observation, you just pay attention to those, and some of them are more important than others. We have different health checks. We have global, table level, index level. Now, the actual health checks are over 100. I don't mention all of them here, I just mention some of them here. I'm just going to go through this slide so you can see what kind of health checks we do. Right now we're looking at global health checks. For example, here we're doing health checks about system statistics, about baselines, about client history, about profiles. When we have a data type conversion, implicit data type conversion, when we have predicates out of range, then table level, we check the degree of parallelism, blocks, no statistics, no rows. All these pieces are regarding statistics about the table. Many health checks for tables. Sorry, this one here. Then we have health checks for indexes. Number of listing values doesn't match the number of rows. Some cross-reference between statistics, like the number of listing values is not matching the number of listing keys. On an index that has a single column, they should be the same. When we have indexes that are non-usable or invisible. So what is the output? I already showed you the output. The output is quite large. We have many pieces on the output. We usually look first here, observations, so we look at the health checks. All those pieces are from the section that says observations. Then we have a summary for tables, which are basically to do a compare between two systems, but visual compare. We don't have a compare method here. For indexes, we have the same, so we can do a compare between two systems. Diagnostics, we have many entries. I already navigated through some of these entries. On the output, we start here by looking at observations. And then we navigate every other piece. I mean, we look at the table summary, index summaries. We look at execution plans. This is the demo of the SQL health check, which is the one that I executed, and the references. That was the first PowerPoint. We have already covered everything. I didn't go into the detail explaining one by one all the hundreds of health checks, but you have an idea what kind of health check we have. And the last PowerPoint that I have is regarding test case. For test case, I show you how I was able to reproduce the same plan. Remember I took the test case and reproduced the same plan? Remember that? Yes? No? Okay. So here this PowerPoint is how do we create a test case in 5 minutes. Actually the test case is already created. It's how do we implement a test case that is coming from SQLTXPLAIN very fast. And it actually doesn't take more than 5 minutes. So this is an introduction to SQLT. The main point here is the demo, which is what I did. So it has an introduction why we need a test case. What are the pieces that we need? We need metadata, we need CBO statistics, SQL text, we need a similar system. But we also need binds, we need CBO statistics for the system, the CBO environment. We need to remap the schema owner. So if in the source system I have a schema names A, B, and C, I consolidate everything into one schema name, which is called PC something, right? So that means I can create a test case even on the same system. I can create a test case in production. Why? Because it's self-contained. I can do that manually. If I have two environments, let's say production and development, and I have the same objects, I can just migrate the statistics and pretty much I am done. I may need to take care of the CBO environment or maybe system stuff, but doing it manually when the two systems are very similar is easy. Second method is with the test case builder from 11G. There are some APIs. Third method is with SQLTXPLAIN using the TC. This is the one that I demo. Fourth method is this one, TCX, which is more internal. This is new. Those are the four methods. How can we use a test case with SQLT? Well, SQLT gives you the three methods. It gives you test case builder, SQLT test case, and SQLT test case express. We have 3 test cases on SQLT. There are some pros and cons. All the methods, they give you everything. But this one only is available if you are on 11G and only if you use one of these 3 methods. The other methods are available on 10G and 11G, regardless of the method. These two, the SQLT test case or test case express, are very easy to implement. I showed you this one here. I use SQLTC express. This is another method to implement the same test case where I go step by step. This is just one driver that executes all these 7 steps. And this SQLT-PCX, you only have the express, but instead of being called express, it's called install, which is just one step, one big step. So where do I find the test case? The test case is inside the SQLT main file, where I can find the main report, I can find the README, and I can find the TC. I need those 3. Regardless of which method I use, I may have different files, but in every case I have the README and I have the TC. The TC is a zip file, and the README is just a file that basically contains instructions to implement the test case. Remember, this is the same README that has the instructions to implement the SQLPLAIN baseline. Remember that, like the one that I was showing you? So this README is very important to do things like test case, to do the SQLPLAIN baseline, to gather statistics, to use compare. Those instructions are here on a dynamic file. So what is included on this test case? It has many files. You can see all those many files. Among those files, most of those files are used directly by the test case. We have some metadata script, some purge script, the export of SQLT, some restore script, the setup of the system statistics, the setup of the CV environment, the actual test case, which contains the SQL that we want to execute, and the display of the execution plan. We also have the express scripts, some miscellaneous utilities, and we also have the README. This README that you see here is the same one as the README that we saw for the SQLPLAIN baseline. Remember on trace analyzer, I gave you trace analyzer in two formats, HTML and text, the same report. And you guys told me the reason is because some people prefer to read text, some people prefer to read HTML. The README here, this one, is the same thing. It's the same content. I give you the same content on HTML and on text. Why? Because if you are working everything on the server, you don't want to go back to a laptop to read the HTML. You want to read from the server, right? So you do a VI, and then you can read this file. It's the same content, or different format. Okay? Anyway, metadata script is the one that creates the schema objects. It allows me, if I want to, I can change the name of the test case and add a suffix. And usually I don't use those customizations. I don't have to change those names. So in most cases, when I run the metadata script, everything is going to be fine, everything is going to be valid. In some cases, I get some invalid objects. If invalid objects are synonyms, I can ignore them. If those are libraries, they may require some attention. If they are views, they do require attention. What kind of attention? I usually need to come to the view inside the metadata and look at the from clause. And if the from clause has a reference to the schema names, I just remove the schema names. It's very easy. This is an example of the metadata script. It contains a small section that we can customize. How many times I use this section so far? Never, never. I didn't create this section to be consumed by myself. I created this section because someone asked me to create this section, so we need to customize. I don't need this, so I suggest you just skip this portion. This purge script is going to avoid collisions. If you send me a file that says 1, 2, 3, or 5, 1, 2, 3, 4, 5, and then another customer sends me the same 1, 2, 3, 4, 5, which means I have a collision, I run the purge script automatically, so I remove the collision. So if I was working this case last week, and this week I'm working this other case for a different customer, it happens to have the same ID, I just remove the problem. This has been here, this provision has been here. So far, I have never had a collision myself. Okay? So collision is like 1 in a million times. I never had a collision. So that would be the purge script. Then the export of the dump file. This dump file contains the SQLT repository. And every time I run SQLT, I have the repository. Keep in mind, I do not bring data, but I bring metadata. About that file, how do I bring over that file? I just issue this command, this import command, and I get the repository. Restore script, that is the one that is going to match my repository to my new objects. So this one is doing the mapping between the object that you have and the object that I have, and it's taking your statistics and creating those statistics inside my object. Is that clear? That is what it does. System statistics is just bringing over whatever system stats you have. How do I bring them over? I delete my system stats, and then I restore my system stats using set system stats according to the value that you have. regarding the CDO environment, this is a script that is going to do a lot of alter session commands and some alter system commands, just a few alter system commands, which is going to allow me to mimic your CDO environment. Whatever you have as your CDO environment, I copy the CDO environment. This test case script contains two entries. It executes the SQL. This script contains your SQL, followed by the one here, which basically displays the plan. When I use the express method, I have a couple of scripts, SH and SQL. SH, basically what it does, it executes the SQL. And this SQL, what it does, it executes the same 7 steps as the custom implementation of the test case. So if I map all those scripts to where they are inside the TC file, they are there. Those are the ones I need. And those are utilities. I already showed you the scripts which are part of the test case, and these are basically extra parts, miscellaneous utilities. Now, how do I implement the test case? I unzip the main file, then I will be looking here on the main file. I need the README, I need the main HTML, and I need the TC file. Those are the ones I need. I unzip that, I look at the main report, and then I look at inside the README, I look for this entry that says implement SQL test case. This is going to guide me to say what did I need. This one says copy this file to the target and then prepare the test case. Preparation is very simple. Preparation, this is the README. The README, I just click on this link and it's going to say unzip this file, go to that directory, and then if you do the custom implementation, you follow 7 steps. Those 7 steps, they have pointers basically to scripts inside the test case. But if you choose the express, it's only 1 step. Guess which method we use all the time? 7 steps, 1 step. 1 step, right? So 1 step. But this 1 step, which the shell executes this script, if I open this script, look what I find inside the script. We find the same 7 steps. Custom and express are the same. Express is just a wrapper, so I don't have to cut and paste command by command. All the commands are here saying step number 1 of 7, 2 of 7, 3 of 7, so on, 7 of 7. So that means I can go back and forth between the custom implementation and the express implementation. It doesn't matter. If I have to stop at some point and fix something, I start with express. If something breaks, let's say metadata is broken, I need to fix it, then I can come back and either I re-execute the express or I do the custom. In any case, it doesn't take more than 5 minutes. Demonstration, I already did the demonstration. I used TC with the express method. Remember I did that and it was asking step by step. Remember this? Yeah. Okay. So what else do we have? Well, once we create the execution plan that we like, then we can start playing with the what if. What if? Well, what happens, for example, if we have a regression? In other words, we did an upgrade, and after the upgrade, the performance of this SQL broke. We say, you know what, I am suspecting it was the upgrade. So I can say, alter session set optimizer features enabled to the prior release, to the pre-upgrade. And if I execute my SQL standalone, and the performance is back to normal, I can pretty sure say, this SQL was broken because of the upgrade. Is that clear? So we can do that. That's easy. And that would be kind of a workaround. I know that if I want to execute a SQL, I just need to do alter session, set optimizer features enable, and put it back to the release I had. Run the SQL, and fine. But now, the question is, how do I find which particular fix of the optimizer is the one that is affecting my performance? To narrow that fix, we use this method, SQLTXPLAIN. Now, if we're suspecting it is statistics, I may want to use on a test environment, I may use SQLTXSum. If I am suspecting histograms and I want to modify histograms on my test environment for my test case, I may want to use this method. There are some extra methods, these are advanced methods. So these are basically what happens after we have the test case. How do we play with the test case? Now, if later on I discover, yeah, I have a case, I need to open a bug to development, this is more the internal. If I want to open a go to development, I want to create a test case out of my test case, but without SQLT. I want to remove SQLT from the equation. Why? Because if I pass to development a test case where they need to implement SQLT, guess what? They will say, no. Give me a plain test case where there is no tool. Is that clear? So this is basically a method to do that. I won't go to this one because it's more different between support and development. How they go from SQLT to no SQLT for the test case. Is that clear? References, the same references, and we are done.